Hello, ladies and gentlemen. Here we are looking at Unit 2, Lesson number 8, Direct and Partial Variation. Our learning goals for today: the initial value determines if a linear relation has a partial variation or direct variation. Our success criteria is to determine partial and direct variation in linear relations. And our practice is the Activity 8 Outfitters Part 1, Partial and Direct Variation. On our hub page, you can access this document right here, and it will be the option directly above the video that you're watching now. So, for our lesson, we are using the Outfitters activity. In this Outfitters activity, Jared wants to rent a canoe for a day trip. He gathers this information from two places and decides to make a table of values and graph each of these relationships. So, we're looking to go on a trip. We call up two separate outfitter stores, and we're going to make a comparison. First of all, Big Pine Outfitters charges a base fee of $40 and $10 per hour of use. So, Big Pine Outfitters, which we are going to see again down here. Okay. Hemlock Bluff Adventure Store does not charge a base fee, but charges $30 per hour to use the canoe. So Hemlock Bluff Adventure Store, right there. So we've got some important information here. We've got a base fee of $40, and then we've got $10 for an hour of use. With our second store, we've got no base fee, and then $30 per hour of use. So our table of values here shows, first of all, for Big Pine, are $40 and are $10 for each hour. In this question, if we used a time of 0 hours, we would get the base fee of $40 and $10 an hour for 0 hours, giving us a cost of $40. If we were using 1 hour, we would still have our $40 an hour, plus we would get $10 an hour times 1 hour, giving us $50 for a cost. Looking at Hemlock Bluff Adventure Store, if we were to use the fee, we don't have a single base fee to charge, but we do have $30 for each hour used. So, if we were to take this canoe out for 0 hours, it would cost $0 because there's no base fee, and $30 times 0 hours is 0. If we take the canoe out for 1 hour, we have a $0 base fee, but we have $30 times 1 hour to give us a cost of $30. For 2 and 3 hours, we have these prices shown, $60 and $70. Take a minute and use this space on your worksheet in order to calculate the costs like you did for 0 and 1 hour. Alright, so everyone should have paused their video and worked out the cost for 2 and 3 hours. We'll now take a look at those together. If we did $40 base fee plus 2 hours at $10 an hour, we would get $40 plus another $20. This gives us our cost of 60 like we see for our cost at 2 hours. If we were to look at the cost for 3 hours, we would again take $40 as our base fee and then do $10 times 3 hours. So 40 plus 30, which gives us a cost of $70, which we see right there. This confirms that we've done our work correctly. We're going to move on and look at the costs for the Hemlock Bluff Adventure Store. Just give me 1 second to clear my screen. Alright, and so looking at the Hemlock Bluff cost, if we have a cost from 0 hours, we do 30 times 0 to give us $0. And if we're looking at 1 hour, we're going to do 30 times 1 to get 30. The reason we don't have any addition here is because up in the question we're told there's no base fee. So we're going to work out the cost at 2 hours and at 3 hours in the space on the right. You should all be pausing your videos at this time and working it out, and then we can take a look together. So because we don't have a base fee at the Hemlock Bluff Adventure Store, we're just going to take the cost of $30 an hour and multiply it by the number of hours. So for 2 hours as our time, we'll do 30 times 2, which gives us $60 as our cost. And we see that right there. For a time of 3 hours, we're going to do 30 times 3, which gives us a cost of $90, and that lines up with what we see on our sheet right there. So all of this lines up. We know that our table is correct. I'm going to just clear my screen here, and then we're going to take a look at the graphs. For the Big Pine Outfitters, our graph shows our time that we take out the canoe versus the cost in dollars. We see that at 0 hours, the base cost is $40, and that for every hour, the cost goes up. Our line of best fit here shows us the relationship for each hour that we increase our use. For our second outfitter store, the Hemlock Bluff Adventure Store, we see our time and we see our cost, just like in the first graph. And we can see our cost per hour. Because the Hemlock Bluff Outfitters do not charge a base fee, this graph starts with a cost of $0 at 0 hours. And every hour, our cost rises. Our line of best fit again shows us the relationship of this line. So, we're going to take a look at question number 1 here. In question 1A, what is the cost of each canoe if Jared cancels his reservation? So this is asking us, if we were to have reserved our canoe and then decide to cancel, how much would it cost? Well, if you cancel your reservation, that means that you have had the canoe for 0 hours. In order to find this, we'll look at the time of 0 on both graphs. Notice, with the Big Pine Outfitters, you have to pay $40. whereas with the Hemlock Bluff Adventure Store, you pay nothing at all. This is because the Big Pine Outfitters charge a base fee, and Hemlock Bluff does not. So, we are going to make statements that explain how much Jared has to pay. For Big Pine Outfitters, the base cost was $40. So, if Jared cancels his reservation, he will have to pay Big Pine Outfitters $40. For Hemlock Bluff's Adventure Store, the base fee was $0. This means if Jared cancels his reservation, he will have to pay Hemlock Bluff Adventure Store $0. Question B asks us to compare the rate of change of cost for Big Pine and Hemlock Bluff to the cost per hour of each outfitter. So we've learned in the past that our rate of change is a comparison from one point to another, and that we find it by taking our rise and our run. We can do this for both of our questions. I'm going to write them out on our board, and then we can take a look at our rate of change. So we'll start by looking at the Big Pine Outfitters. We'll take a look going from one point to another. Well, we have a height or a cost of 40 compared to a cost of 70. So that means that we are going from 40 up to 70, giving us a rise of 30. 40 happens at 0 hours, and we move all the way over to 3 hours. So our run is 3 hours. We'll do the same thing for Hemlock Bluff Adventure Store. We are going to start down here at $0 and 0 hours, and then go over to 3 hours and a cost of $90. So we have to get our rise. Our rise is going from 0 all the way up to 90. So we have a rise of $90. And our run is going from 0 hours to 3 hours, giving us 3 hours. We need to figure out our rise over run. So, for Big Pine Outfitters, rise is $30. Our run is 3 hours. 30 over 3 is the same thing as $10 for 1 hour. For Hemlock, we've got $90 over 3 hours. So that simplifies down to $30 for 1 hour. So we've got our rate of change for both of our two outfitters. And the question says, to do this, we need to compare the rate of change to the cost per hour. Well, if you notice, $10 an hour is given to us above in the description. So our rate of change is our cost for each hour. For Hemlock, $30 for 1 hour matches up with our charge of $30 an hour. What this means is Our rate of change is our cost per hour for both questions. And so, quite a bit of work was required there for a very short sentence, but to answer question B, we have to be able to say that the rate of change for each outfitter store is the same as that store's cost for 1 hour. The reason we've done this is to try and associate that cost in a word statement and rate of change on a graph have the same role. So for the video, I have copied the graphs that we were working on the first page for our work here on the second page. This is because we need to look at these graphs in order to answer questions 2 and 3. So question 2 asks us, which graph illustrates a proportional relation? How do you know? This is called a direct variation. So in this question, we're introducing a lot of new words. When we talk about a proportional relation, we're talking about ones that have the same changes. Now, this graph would have to increase for time and increase for costs, which we see right here. The Hemlock Bluff graph is going to meet the criteria for a direct variation. Now, when we talk about direct variation in this class, all you need to concern yourself with is that the initial value is 0. So we make a statement to answer our question. In question 2, the initial value for the graph of Hemlock Bluffs is 0. This means that it is a direct variation. For question 3, which graph has an initial value other than 0? This is called a partial variation. Looking at our graph, Big Pine has an initial value of 40. This is not 0. If the initial value is not 0, it is a partial variation. And so, like we did in our question 2, for question 3, we're going to make a statement. The initial value for the graph of Big Pine is not 0. The initial value is $40, and this means it is a partial variation. Before we move on, I just want to summarize those two ideas. If we have a graph, and that line starts down at 0, it is a direct variation. However, if we have a graph and it starts anywhere else, then it is not direct. It is instead called a partial variation. Okay? So direct can only start at 0 for the initial value, and partial can start anywhere but 0 for the initial value. Moving on, I'm actually going to leave question number 4 for you to do as your practice work for today. Okay? So the question asks you, which outfitter company should Jared choose if he estimates he will canoe for 0.5 hours, 1.5 hours, 2.5 hours? it's going to be your job to find the cost for each of these times. So you need to get the cost for 0.5 hours, 1.5 hours, and 2.5 hours, using the same method that we used at the start of this lesson. Moving on to the last page, we have a bit more to do. Questions 5, 6, and 7 are moving ahead to the next lesson. So what I would like is for you to spend some time working on these 3 questions, and we're going to look at them at the start of lesson number 9. Alright, that's going to be it for today. I hope everyone is well, and if you have any questions, feel free to send me an email. Take care for now.